In this video, we are going to have a look at the definition of the lattice energy, electron affinity, and ionization energy. Also, explain the effect of ionic charges and ionic radii on the magnitude of the lattice energy. So here, you can see we got two definitions of the lattice energy. The first definition is about energy released when 1 mole of ionic solid compound formed from its gaseous ion. This is an example of the formation of the sodium chloride ionic solid. So the sodium chloride ionic solid is formed from sodium plus gases and Cl minus gases. Okay, so since this is the formation of the bond, the enthalpy lattice here got negative sign, which is it indicates that the process is an exothermic process. While the second definition is about energy absorbed when 1 mole of ionic solid compound is separated completely into gaseous ion. So here we got this 1 mole of the sodium chloride ionic solid breaks into the sodium plus gases ion and Cl minus gases ion. So if you notice here, this process got a positive sign of the lattice energy. So it means that the process is an endothermic process. So formation of the bond is an exothermic process. The breaking of the bond is an endothermic process. For the electron affinity, there is an energy change when 1 mole of gaseous atoms gain 1 mole of electron to form an ion. So why does here we use the term energy change? It is because only for the first electron affinity, for example, here we have an oxygen gaseous atom. The 1 mole of oxygen gaseous atom is gain 1 mole of an electron. It will produce 1 mole of oxygen gaseous ion. Okay, O minus. All right, so just add the negative charge on your handouts. Okay, so if you notice here, this one will release energy. It is an exothermic process for the first electron affinity of the oxygen. But then for the second electron affinity of oxygen, okay, so from the 1 mole of gaseous ion, okay, O minus gas added another 1 mole of electron, it will produce O2 minus gas. Okay, so here, if you notice here, the sign here is a positive sign. So the first electron affinity is an exothermic process, while the second electron affinity is an endothermic process. This is because, okay, you are forcing 1 mole of electron into a negatively charged of oxygen ion. Okay, so this oxygen ion is already got so many electrons. All right, so you are forcing another 1 mole of electron into the ions that already have more electrons. So that's why we need an energy to do that. For the ionization energy, it is a minimum energy required to remove 1 mole of electron from 1 mole of gaseous atoms or ions. So this one is basically an opposite of our electron affinity. So electron affinity is you want to add 1 mole of electron. For the ionization energy, you want to remove 1 mole of electron. Okay, so since you want to remove the electron, okay, so you will need energy. So that's why minimum energy required. All right, so for an example here, okay, the first electron ionization energy of the magnesium, okay, so 1 mole of magnesium gaseous atom produce 1 mole of magnesium ion, Mg plus gas. Okay, so when you remove 1 mole of electron from the magnesium atom, you will need 738 kilojoule per mole. Okay, but for the second IE, second ionization energy, so just change it into IE2, okay, we are going to remove 1 mole of electron from a positively charged of magnesium ion, okay, and then it will become Mg2 plus gas. All right, so since we are going to remove the electron from the positively charged of ion for the second ionization energy, so if you notice here, we will need more energy. So as we remove the electron, okay, so the ionization energy will increases for the next electron that we are going to remove. This is because when you remove the electron, the size of the ion form will become smaller. So there is a strong attraction between the nucleus and the remaining electron. That make you need more energy to remove the 1 mole of electron from that particular ion. So now let's have a look at the effects of the ionic charges and ionic radii on the magnitudes of the lattice energy. So basically, lattice energy is directly proportional to the ionic charge and inversely proportional to the ionic size. Okay, so as the ionic charge increases, lattice energy is also increases, while as the ionic size decreases, the magnitude of the lattice energy is increases. So increasing the ionic charge actually will increase the lattice energy, which is it will make it more negative or more exothermic because the electrostatic forces attraction between ion increases. So the strong electrostatic forces attraction between the ions will make the lattice energy increases, while decreasing the ionic size will increase the lattice energy or make it more exothermic because the electrostatic forces attraction between the ions will become stronger and makes the ions closer to each other. So that's why it will make the lattice energy more exothermic. So let's have a look at this example. Compare the lattice energy of magnesium fluoride and magnesium oxide. Give your reason. So the one that is different here is the fluoride and also oxide. Where in magnesium fluoride, okay, so we have two ions, which is the Mg2 plus ion and 2F minus ion. While in magnesium oxide, we have Mg2 plus ion and O2 minus ion. So here, the one that is different is the fluoride ion and the oxide ion. Since the fluoride ion only got -1 charge, while the oxide ion got O2 minus charge. Since the ionic charge of O2 minus is bigger than F minus, the electrostatic forces of attraction in Mg2 plus and O2 minus is stronger than between in Mg2 plus and F minus ions. Thus, the lattice energy of the magnesium oxide is bigger than magnesium fluoride. In lithium fluoride and sodium fluoride, okay, so lithium fluoride got lithium plus ion and fluoride ion, F minus ion, while in sodium fluoride we got Na plus ion and also F minus ion. So the one that is different here is the Li plus and Na plus ion. So since the charge is the same, which is +1 and also +1, the effect that we are talking about here is about the ionic size. So lithium and sodium are in the same group, which is group 1. So lithium plus ion is smaller than sodium plus ion. So the electrostatic forces of attraction between lithium plus and F minus are stronger than in Na plus and F minus ions. Thus, the lattice energy of lithium fluoride is bigger than the sodium fluoride. So here, to answer the question regarding the effects of the ionic charge and ionic radii on the magnitude of the lattice energy, okay, first you take out the ions in both compounds that you have, okay, and then find the one that are different. For example, in magnesium fluoride and magnesium oxide, magnesium is the same thing, so just ignore it. So we are going to compare the F minus and O2 minus. So since here, if you look at here, the charge is totally different, so we are going to discuss about the ionic charge. While in this example, so the one that are different is the Li plus and Na plus. The fluoride ion is the same for both compounds. Okay, so since the charge is the same, which is the positive one, then we are going to discuss about the ionic size effect on these two ionic compounds.